Imagine looking up at the sky and seeing something impossible. Not a star, not a planet, not a galaxy, but a dark circle so massive that even light cannot escape it. Now imagine that this dark object is so large that our entire solar system, the Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and everything in between could fit inside its shadow. This is not fantasy. Somewhere in the distant universe, there are black holes so enormous that our solar system would look tiny beside them. These are not normal black holes created by dying stars. These are supermassive and ultramassive black holes. Cosmic monsters sitting at the centers of galaxies. And some of them are so huge that if one were placed where our Sun is, Earth would already be far inside the danger zone. But before we understand the monster, we need to understand what a black hole really is. A black hole is a region of space where gravity becomes so powerful that nothing can escape once it gets too close. Not dust, not gas, not planets, not stars, not even light. The boundary around a black hole is called the event horizon. This is the point of no return. Once anything crosses this invisible line, it can never come back. The strange thing is that the event horizon is not a solid wall. You would not hit a surface. You would simply cross an invisible border in space. But after that moment, every possible direction would lead deeper inside. For small black holes, the event horizon may be only a few kilometers wide. But for the largest black holes in the universe, this boundary can stretch across distances bigger than entire planetary systems. One famous example is TON 618, one of the most massive black holes known. It is estimated to have a mass around 66 billion times greater than our Sun. Our Sun already contains more than 99% of all the mass in the solar system. Every planet, moon, asteroid, and comet combined is only a tiny fraction compared to the Sun. Now multiply the Sun by 66 billion. That is the kind of scale we are dealing with. If our Sun were replaced by a black hole with the same mass as the Sun, Earth would not instantly fall in. It would keep orbiting almost normally because the gravity at Earth's distance would be about the same. But TON 618 is not one solar mass. It is billions of solar masses. A black hole that massive would have an event horizon so enormous that the inner solar system would disappear inside it. Mercury, Venus, Earth, and Mars would not orbit around it safely. They would be swallowed by the black hole's boundary. And depending on the exact size, even the outer planets would be in extreme danger. This is what makes ultramassive black holes so terrifying. They do not just destroy objects. They make distances that feel huge to us look meaningless. Earth is about 150 million kilometers from the Sun. Light takes more than 8 minutes to travel from the Sun to our planet. That distance feels enormous. But next to an ultramassive black hole, it is almost nothing. If such a black hole appeared near our solar system, the destruction would begin long before anything crossed the event horizon. First, the outer icy bodies and comets would be disturbed. The distant objects at the edge of the solar system would be thrown into chaotic orbits. Then the planets would begin to lose their balance. Jupiter, Saturn, Uranus, and Neptune would no longer move in their stable paths. Their orbits would stretch and twist under the black hole's gravity. Earth's orbit would also become unstable, and Earth depends completely on stability. Our planet survives because it orbits the Sun at the right distance. Not too hot, not too cold, stable enough for oceans, atmosphere, and life to exist for billions of years. A giant black hole would destroy that balance. The night sky would change first. Stars behind the black hole would look distorted. Some would appear stretched into arcs, others might look duplicated. Light itself would bend around the black hole because gravity warps space. This effect is called gravitational lensing. A black hole does not need to reveal itself. It reveals itself by bending the light of everything behind it. But the black hole itself remains completely dark. This darkness is different from ordinary darkness. A planet may look dark because it reflects little light. A black hole is dark because light cannot escape from it. It is not hiding in the darkness. It is creating the darkness. Around many huge black holes, there is something called an accretion disk. This is a spinning disk of gas, dust, and broken material falling toward the black hole. As this material moves inward, it heats up to extreme temperatures. It can become so bright that it outshines an entire galaxy. That is one of the strangest things about black holes. The black hole itself is invisible, but the material dying around it can become one of the brightest things in the universe. If a star gets too close, the black hole does not simply swallow it whole. The gravity on the near side of the star becomes much stronger than the gravity on the far side. This difference stretches the star, tears it apart, and pulls it into long streams of superheated gas. Scientists call this tidal disruption. Some people call it spaghettification. It sounds almost funny, but it is one of the most violent events in space. A star larger than our sun can be ripped apart and turned into glowing rivers of plasma before falling into the black hole. Now imagine our solar system facing that kind of force. The sun itself would not survive. The planets would not remain in order. The peaceful structure we know would collapse into chaos. But the most disturbing part is not only gravity. It is time. According to Einstein's theory of general relativity, gravity affects time. The stronger the gravity, the slower time passes compared to places farther away. Near a black hole, this effect becomes extreme. To someone watching from far away, an object falling toward the event horizon would appear to slow down. It would become dimmer, redder, and almost frozen near the edge. From the object's perspective, time flows normally as it crosses the event horizon. But to anyone far away, no light or signal can escape. Inside the black hole, physics reaches its greatest mystery, a singularity, where density becomes infinite and the laws of physics break down. Black holes are more than destroyers. They are cosmic laboratories where general relativity and quantum physics collide. Supermassive black holes, like Sagittarius A, in our galaxy can contain millions of suns, while monsters like TON 618 are billions of times more massive. These giants shape galaxies, releasing powerful jets of energy, heating gas, and controlling star formation. They are destruction at the center of creation. Dark, yet shaping some of the brightest regions of the universe. Could one threaten our solar system? Almost certainly not. They're locked in distant galaxies. The real terror is scale. Objects so massive that our entire solar system could fit inside their shadow. Black holes are not just holes in space. They are holes in our understanding.